So hello everyone. So today we are going to see about the classification of ligand basis on the donating sites. Okay. So this is also now a very important topic. We are going to discuss about the classification of ligands, and here number of examples I will give you of the ligands. That names you should remember, and you should also remember the structures. Okay. In the next class probably I will start with the giving the naming of the ligands, and we will see the IUPAC nomenclature of the coordination compound. Clear? So you can make a heading, the classification of ligands, classification of ligand, clear, on the basis of its donor sites. The classification of ligands we are going to see on the basis of its donor site. First is monodentate, second is bidentate, okay. There is also tridentate, tetradentate, but all to them I am categorizing in a polydentate also, okay. Third, you can write down the ambidentate, Fourth, I can write down the polydentate. Chalo. Polydentate. We will see this one by one. First, we will see the monodentate. Okay, here dentate means teeth. Teeth means donor side. Okay. Dentate or denticity. In your book, they have given this also, denticity. So don't get confused. If it is a dentate or denticity, is nothing but your donor sites. Donor site, that's it. Okay. If there is one donor site, monodentate. If there are two donor site, bidentate. Three donor site, tridentate. Four donor site, quadridentate, or five, then we say the polydentate, and one is hexadentate. This is also one important which will come under the polydentate. Okay, this part. So more than a 2, if I write down, you understand this is a case for the polydentate. Clear this part? Now first write down the definition of monodentate. See, monodentate means what? I told you dentate or denticity means what? Donor side. So monodentate ligands are the ligand which have only one donor side. So write down a monodentate ligand. Write down along with me only. A monodentate ligand. A monodentate ligand is a ligand which has only one donor sites, which have only one donor site, which is used to bond, which has only one donor site, one donor site to bond with central metal atom. The central metal atom. See, or ion. Central metal ion. Clear? So monodentate ligand means what? A simple logic. Mono, one, dentate or denticity or donor site. So monodentate ligand is a ligand which has only one donor site, which can donate only one time electron. Clear this part? Which has only one donor site. Example I will tell you. See, example is Cl minus. This is only, it can donate one lone pair. So this is monodentate ligand. Br minus, F minus, OH minus. Yes or no? See this OH minus, how it is formed? OH and here H. So this H is breaking, no? So here it will convert into OH minus. So actually OH minus is on this oxygen, not on this hydrogen. See here? Yes or no? So minus is on the oxygen. So this oxygen will donate its only lone pair. Hydrogen cannot donate. Only oxygen can donate. Yes or no? Hydrogen is in a bonding with oxygen. So hydrogen cannot donate. This minus charge is on this oxygen. So oxygen only can donate. Only one site is there. Oxygen site. This site is not there. Hydrogen cannot donate. Here there are two atoms. So you are thinking two sites. No. This hydrogen is in the bond with oxygen. And this minus charge is on the oxygen. So oxygen only can donate or can make a bond with some other central metal atom or central metal ion, not the hydrogen. So we say as a monodentate ligand. Next is H2O. Now see here. So H2O has 2 lone pair. Out of 2 lone pair, he can donate only 1 lone pair to one central metal atom. 2 of the lone pair cannot be donated. Clear this part? Out of 2 lone pair on the oxygen, only 1 lone pair will be donated to central metal atom. 2 of the lone pair cannot be donated. Then next is ammonia. It is also having 1 lone pair. No, this nitrogen is only having 1 lone pair. Then we can write down methylamine. Yes or no? Methylamine also. See, this is methylamine. 1 lone pair only. So only one side to donate. Here there are 2 electron beta, but out of 2 electron, 1 only they will donate. Another will not be donated. So H2 is a not bidentate. It's a monodentate. Understand? If you see these 2 electrons, don't understand. Oh, 2 sides. Only there is 1 side. 1 oxygen is only donating. No. See this. We have to see the sides, not the number of electrons. We have to see the side. Jagya jovani che. Electron thi jovana. So this is H2O. So this oxygen only have a capacity to donate, not this hydrogen. So only there is 1 side. So it is a monodentate. Clear? Similar this amine, methylamine. Okay. So these are the certain examples of monodentate ligand. Write down this. Clear? So what do you mean by monodentate ligand? A monodentate ligand is a ligand which has only 1 donor site. Understood the meaning of site? And one who donate. The atom which donate the electron is known as donor atom. Out of this oxygen and this hydrogen, I shown you that this oxygen will donate the electron. So this oxygen is a donor atom. Similarly, in this methylamine, this nitrogen will donate its lone pair. So this nitrogen is known as a donor atom. Okay. So what do you mean by donor atom? The donor atom is one which donate the lone pair of the ligand. So ligand ના અંદરમાં જે atom donate કરે છે એ atom ને આપણે શું કહેશું? Donor atom. Clear this part? Clear? Understood this monodentate? Understanding or not? Here number of examples you have to see. Okay. Clear this part? Clear? Now next I will go with the bidentate ligand. See here. I hope you written, no? Next we will go with the bidentate ligand. Bidentate ligand. What can be the definition? Bidentate ligand are the ligand which has the 2 donor side or which can donate from 2 sides. 2 donor sides are there. 2 lone pair nahi, 2 donor side. Side jagya hovi જોઈએ. So 2 donor side and they can donate the electron from 2 donor side to the center metal atom or center metal ion. Write down. Bidentate ligands are one which has 2 donor atom or sites or 2 donor sites. 2 donor sites. See here I am nowhere mentioning electrons. જેને 2 ઇલેક્ટ્રોન હોય બાયડેન્ટેટ ના થાય. સાઇટ જગ્યા જોવાની છે કે એક લિગેન્ડમાં કેટલા એટમ આપે છે. અગર એક લિગેન્ડમાં એક એટમ લોન પેર આપી શકતો હોય તો મોનોડેન્ટેટ. 2 એટમ ઇલેક્ટ્રોન આપી શકતા હોય બાયડેન્ટેટ. 3 આપી શકતા હોય ટ્રાઇડેન્ટેટ. 6 આપી શકતા હોય હેક્સાડેન્ટેટ, પોલીડેન્ટેટ. So we are not seeing the electrons. A ligand which donate 2 lone pair bidentate. No. Ligand, this bidentate ligand is a ligand which has a 2 donor atom or there are 2 sides. 2 atom માંથી electron મળી શકે કેટલા પણ 2 atom માંથી મળશે. Clear this part? So bidentate ligand are ligand one which has a 2 donor atom or 2 donor site which binds or which bond or 2 donor site to make a bond with central metal atom or central metal ion. Clear this part? See the example. Example is very important. So first example is ethylene diamine. Okay. In shortcut we are saying EN. Now see here. Beta, this is ethylene. Yes or no? One bond breaks. So here one amine, here one amine. This nitrogen will have 1 lone pair. This nitrogen will have 1 lone pair. So see, This is bidented ligand. There are two atoms in this ligand which are donating its lone pair. See, this is one atom, this is one atom. So how many donor atom will be there in bidented? So there are two donor atom because there are two sites. Site number 1, site number 2. So this is a bidented ligand. Understanding? So bidented ligand is a ligand in which there are two donor atom or two donor sites. So this is donor site 1, this is donor site 2. From here also bond will come, here also they can do the bond, here also they can do the bond. So this is the donor atom size now. Okay, there are two donor sites. If you see the monodentate, if you see the previous video, you will see that there was only one donor site, like Cl minus, Br minus, OH minus, and then only O was there. Ammonia, only nitrogen was there. H2, only O was there. Here you see there are two nitrogen, there are two amine group which will donate. So these are the two donor site. Second example, if you see, see, now C2O4 minus 2, this is nothing but your oxalate ion. Now in this chapter you cannot say oxalate ion. Wherever you see minus charge, negative, wherever you see negative ion, you give a suffix. You give a suffix to, ato. Which is suffix to give? Ato. To. Just to give to, ato or ato. This suffix you give. What is the name of this? Oxalate ion, no? Now you don't say this oxalate ion. You have to say oxalato. Oxalato. Clear? For this chapter, for IUPAC naming I am telling, whenever you see the negative ion, you have to give the suffix as ato, oxalato. So this is not oxalate ion. Now what you have to call? This is oxalato. Now this is not a negative ion, this is a neutral. So I will not say ethylene diamino. No, it is not diamino. This is neutral. This suffix is only for the negative ion, anion. For the anion I am talking about. Whenever you see the anion in the coordination chemistry, they use the suffix as ATO. In the next class I will tell in detail. But now don't say oxalate ion. Now what you have to say? Oxalato, sulfato, cyanido. Clear? See here now. So C2O4 minus is oxalato. So what is the structure? See the structure of oxalato. See. Here double bond O, here double bond O, and here O minus, and here O minus. See the donor side. This is one donor side, this is another donor side. So there are two donor side, so they are bidentate ligand. Third example you can see carbonato. So CO3 minus 2. This is known as a carbonate. Now this is a negative ion. So what you have to speak beta? Carbonato. Carbonato. Okay, so here also there are two donor side. How to see? See, C double bond O. Here one O, here one O, here one O. So this is minus, this is minus. So this is donor number site 1 and this is donor number site 2. Clear? Draw the structure, you understand in detail. Now whenever you see the anion, don't speak carbonate ion. Carbonato, oxalato, sulfato, ato. This name you have to give. Clear this part? You will understand. It's very easy chapter, it's very damn easy chapter, and it's very interesting also. IUPAC naming is damn easy. Just you understand 2-3 logics, each and every name. And the good news is 4-mark question can come from this chapter. And 95% cases, how the 4-mark question will come, you know, they will ask you the 4 IUPAC name of the compound. That's it, over. So more focus on the IUPAC naming. It's easy. Just to remember whatever I tell tomorrow or day after tomorrow, next class, I will give you certain this kind of names and this structure to remember. And all the structures also not to remember. Heavy anions they are not asking. Heavy ligands they are not asking. Simple ligands they are asking. But you have to remember, you have to understand. Clear? Right on next. See, I have many examples here. Okay, just today you have to practice. Chalo. So next you will see. Next. Fourth example is glycinato. Just to say gly. Fourth example is, write down. Fourth, we are in bidentate only, huh? Glycinato. Just you say gly. So this is also one ligand. You can see the structure. Structure is very important. See, double bond O, here NH2, and here O minus. Clear this part? See, this is having one lone pair, so this is one donor side, and this is second donor side. There are two donor sides, so it's a bidentate ligand. Number of electrons here they have not to see. We have to see how many atoms in a ligand they are giving the electron to make a bond. So there are two atoms who are giving the electron, so it is a bidentate. That's it. Here it is not a question based on the electron. Number of the donor sites. This type of a ligands on a donor site we are doing. You have to see how many donor sites are there. 1 mono, bi, 2 donor site, bi, 3 donor site, tri, poly. Clear this part? 5th example. Next is dimethyl glymixato. So sorry, dimethyl glyoxymato. See, this was an anion, no beta. So ato. This is also an anion. Dimethyl glyoxymato. Shortcut is DMG. As here the shortcut is GLY, here the shortcut is DMG. See the structure here. C double bond CH3 dimethyl glyoxymato. So here this is nitrogen and this is here OH. Okay. Clear this part. This one donor side and here this is, here there is one NO minus. So here this is one donor side and this oxygen another donor side. Okay, this part. This O minus is on this oxygen. So this is donor side 1 oxygen and of this molecule the donor side is another is nitrogen. This is one structure of DMG. Understand this structure? You have to remember, you have to mug it up. So this is dimethyl glyoxymato. Clear? Actually it is a dimethyl glyoxymate ion. But I told you no beta that negative ion in this chapter you have to give the suffix as what? Ato. So dimethyl glyoxymato. Write down. One more I have. If the name is ato is given to only anion. If it is a neutral, do not give ato. It is only given to the anion. Now see, as we have seen in ethylene diamine, I have not told ethylene diamine ato. Did I told? No, it was ethylene diamine because it was a neutral. So neutral you should not give the suffix ato. This suffix is only for the anions. See, 5th, 6th case. Written beta. Okay, see the 6th case now. So 6th is 2,2,2-bipyridine. This is BPY. Okay. Now this is not, see, now I have not written here ato. When I have not written here ato means this is not an anion. This is one neutral molecule. See the structure. Sorry. RRR. This is one donor site, this is one donor site. Because of its lone pair, no? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. There are 2 donor site. So I said a BPY, bipyridine. Now see, this is not, here can you see a negative sign? Can you see any negative sign on any atom? No. So I have not given the suffix ato. Clear? 7th. 7th is ACAC. Acetyl acetato. ACAC. Please remember this. Acetyl acetato. Now see, ato is given. Means this is an ion or a neutral molecule. This is an ion. So this will be an ion. See the structure. The structure is in your book somewhere in the competition book they will be giving like this. Sorry. Okay. This is nothing but here acetyl acetato. See the structure, bond length structure also they will be given in the book. This dotted line is showing that this minus charge is resonance between this oxygen and this oxygen. Okay. So this minus charge is resonant between this oxygen and this oxygen, but this is also structure or this is also structure. You can remember this, both the structures are same. Okay. This is acetyl acenato or this is carbon, no beta. Remember this structure only now. See. So there are 2 donor sites. One is this, another one is this. So this is nothing but your acetyl acetato. Clear? After making the bond, they have also this, no? So they have minus charge here, and this minus charge, this dotted line is shown in some of the books. So this dotted line is indicating what? This minus charge will resonance from this oxygen to this oxygen. Clear? So these are the certain examples of the bidentate ligand. Now we'll go to the ambidentate ligand. Take a screenshot. The next I will go to the ambidentate ligand. Done this. Clear? Chalo. Return. Today the class is becoming bit hard, I know, but what to do? This all questions will come in the exams, and this is very easy. Just you practice, mug it up. You'll understand. And this type of question cannot come in the boards. Okay, competition they can come. Okay, and this type of question I guess it is not given in the textbook also. Clear? Chalo. So can I go for the next? Okay. Read. This chapter as much as possible. Read and mug it up. Then all you understand. Okay. Next you can write down ambidentate ligand. So what is this? So first point in this ambidentate ligand, the first point will come, that is this is an type of monodentate ligand. So what is this now? Monodentate ligand. This is one type of monodentate ligand. See, what do you mean by monodentate ligand? Monodentate ligand is a ligand which have only one donor site. Now what do you mean by ambidentate ligand, beta? So ambidentate ligand is also one special type of a monodentate ligand. Why, sir? Ambidentate ligand will have a two donor site. Ambidentate ligand will have a two donor site, but out of two donor site at a time, two he cannot use, only one he will use. Ambidentate ligand is also one type of a monodentate ligand, means, see, in monodentate ligand they have only one donor site. So in ambidentate ligand we have a two donor site. Understand? In ambidentate ligand we have a two donor site, but at a time he cannot donate the lone pair from both the side. Any one of the side he can use, both the side cannot use. So this is a special type of a what? Monodentate, na? Because monodentate is using only one side to donate. So ambidentate has two sides, but out of two sides at a time he can donate only one side. Both the side use cannot be possible. So such a type of a dentate ligand is known as a ambidentate ligand. The best example is Cn minus. Cn minus, if it is a monodentate bidentate, sir, monodentate, no, wrong. It's an ambidentate. There are two donor sites in cyanide ion, the cyanide. Here also is there 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This lone pair, this nitrogen also have, and this carbon is also having. Clear this part? So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So this minus is from this carbon. Now how? HCN. This H will go. C triple bond N. So here minus, one lone pair. 1, 2, 3, 4, 5, 6, 7, 8. So in Cn minus, the minus charge is on the carbon, not the nitrogen. First point. Now here there are two donor sides. Here carbon is also having one lone pair, nitrogen is also having one lone pair. So there are two donor sides, but both at a time cannot do. No, either carbon will do or nitrogen will do. Any one will do. So ambidentate ligand are a ligand which have a two donor site, but out of two donor site they will use only one donor site at a time to make a bond with center metal atom or center metal ion. This is a special case of monodentate ligand. Clear this part? So write down this. We'll see the examples and we'll see the namings also. So cyanide ion, bacha, is an monodentate or ambidentate? It's an ambidentate. Anyone is asking, cyanide ion is a ambidentate. Cyanide ion is a ambidentate. It's not a monodentate like Cl minus, OH minus, Cn minus. Monodentate, no. Cn minus is a ambidentate ligand. It has a two donor site, carbon also, nitrogen also, but at a time he cannot use both the side. Any one side will be used. Clear this part? See here now. So here ambidentate ligand, write down the definition. Ambidentate ligand ambidentate ligand has two different donating sites, but it will use any one of it. It will use any one of it for donating lone pair, but it will use on any one of it for donating to the central metal atom or central metal ion. Okay, so ambidented ligand is a ligand which has a two different donating side, but it will use any one of it. They have two, but at a time they cannot use both. They have to use only one. So this is a special case of a monodented ligand. First is cyanide ion. The best example is cyanide ion. See the example here. Understand this. This cyanide ion has made from this HCN now. See the structure of HCN. HC triple bond N. When this bond breaks, what will happen here? See here now. C triple bond N, and here minus will come. So in Cn minus is not on the nitrogen, it's on the carbon. First point is this. Now count the electron. When H is going as H plus, he will donate. So 2 electron will come here. Now count this electron. 1, 2, 3, 4, 5, 6, 7, 8. So here there is one side of carbon also and another side is nitrogen. But both cannot donate at a one time. Either Cn will be used or N will be used. Clear this part? Clear? And who can give now? So this is the question. Now who will give? Now who will give? Now who will give? So I will explain it to you. Wait a minute. I will explain to you. Now beta, see. C triple bond N. So who is ready to give? See, nitrogen is more electronegative. Nitrogen is more electronegative than carbon. Yes or no? Yes or no? Nitrogen is more electronegative than carbon. Yes or no? Then who is more electronegative element? They will like to keep the electron or they will like to give the electron. They will like to keep the electron, means nitrogen is having this electron, he will be not having any issue, but this carbon is less electronegative. When carbon is less electronegative, so negative charge will not look good on this carbon. So this carbon readily will give the electron. So from here electron will come, not from here. Clear? So as nitrogen is more electronegative element than carbon, so carbon is the donor side. Carbon is donor side. Understood or not, beta? See, out of this carbon and this nitrogen is more electronegative element, carbon is less electronegative element. So carbon is less electronegative element. On this less electronegative element, positive will look good, minus will look good, bad. So here minus is showing on this carbon. So this carbon is minus will look good or bad to this carbon. So minus will look bad on this carbon. So this carbon wants to become stable. So this will give easily electron than this nitrogen. So here site is carbon. See, there are two sides, but who is giving? Carbon is only giving. So carbon is the donor site. Clear this part? Okay, and nitrogen also can give, it's not like that, okay. So both can give, but who is more readily to give? Carbon will be more readily to give. This one question can be asked you. Then a cyanide ion, who can give readily lone pair, or who can make a coordinate covalent bond? Carbon will make readily coordinate covalent bond because carbon is less electronegative than the nitrogen and has a negative charge. So wants to become a stable, so and gives easily lone pair to some other. Now clear this part? So one question was like this, it has been given some books, so I am explaining. Now I will show if the bond is from carbon, what the name should be given, and if the bond is from the nitrogen, what the bond should be given. Again ATO will come, okay, OO will come, ATO. So please remember this now. Written on this, or you can reverse the video and write down the shortcut, write down the first is, see example I am writing, okay, NO2 minus. Now here there are also donor side are two. First donor side is nitrogen, another donor side is oxygen. See here how. So this nitrogen, either this oxygen or double bond this here. If this nitrogen 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if this nitrogen is donor side to metal bond, then this is nothing but this nitrogen is making no. So O. So nitrito N. Why nitrito N? Because N is a donor side, that's why N. If suppose oxygen was the donor side, okay, 1, 2, 3, 4, 5, 6, now this also can donate the electron to the metal, no? So this, if oxygen is the donor side, here in NO2 minus either nitrogen is the donor side or oxygen is the donor side. Both cannot donate at a time, either one atom or another atom. So here it is donating nitrogen. So I will call it as a nitrito N. But here oxygen also can donate. They cannot donate two at a time. Okay, either any one of it. Okay, so if nitrogen donate to the central metal atoms, I will call it as a nitrito N. If oxygen donate, I will say as a nitrito O. Nitrito O. Clear this part? But remember this name. If the bond is through the nitrogen of NO2, I will call as nitrito N. And if the bond is through the oxygen, I will call as nitrito O. Second, we will see Cn minus. So we have seen the two donor side, no? C triple bond N. Yes or no? Or either here or here. I am writing it now here, N triple bond C. If this will donate the electron to metal M, so I will call it as a cyano. Cyano. If N is donating the lone pair to the metal M, so I will call as a isocyano. Isocyano. These names you should remember, okay? If carbon is donating of cyanide, I will call as a cyano. And if nitrogen of cyanide is donating, I will call as a isocyano. Clear? Next. Written know this all? Okay, next. Next example I will go with here. Next example is SCN minus. So here also there are two donating side, either sulfur or either nitrogen. See, if this happens, if sulfur donate the electron, and write down the reverse, N double triple bond C S. If sulfur donate the electron to metal M, so I will say thiocyanato. Thio, this is an anion, no? So ato, thiocyanato. Because the bond between sulfur and thio bond, yes or no? Thiocyanato. And if nitrogen donates to the metal bond, so I will say as a nitrogen means iso. So here also nitrogen means iso. Isocyanato. Cyanato. Isocyanato. Sorry, isothiocyanato. Okay. Isocyanato means what? Only this. Yes or no? But if here S comes, means here sulfur bond is also there. So what I have to call? Isothiocyanato. You have to remember this name. I know this very difficult. Once more when I will do it. But you have to remember this here. Okay. So isothiocyanato. So in this way, you have to remember the anion name. Always remember the anion will be generating the negative ion. Anion will have always suffix as what? Ato. Clear? Clear or not, man? Understanding or not? Clear? So this was a special case. There are many other cases you can read in your textbook. They have given the shortage. If there are 3 donor side tridentate, 4 donor side tetradentate, means if you go beyond 2, all will call as a polydentate. All will call as a polydentate. Now last topic I am going to discuss, that is about the hexadented ligand. Many a time they have asked in the exam about this. So see this. Hexadented ligand. What can be the definition, beta? The hexadented ligand is a ligand which has a 6 donor site. Yes or no? So write down this definition. Next, I am doing hexadentate. That is something but which case? Polydentate only, no? So in polydentate, in polydentate ligand there is a one special case, that is hexadentate ligand. So what do you mean by hexadentate ligand? So write down. One more is there, flexi. Okay, but before I will go with the hexa, that also will come in the, okay, tomorrow we'll see. First write down the hexadentate ligand definition. A hexadentate ligand hexadentate ligand has 6 donor site. 6 donor site. Hexa means 6, no beta? 6 donor site to the to make a bond with central metal atom or central metal ion. Now I am going to discuss a very important part of the chapter. Sometimes they can ask for the 2 marks, just the structure and the type of a ligand and the example, very important example, that is known as a EDTA. Ethylene diamine tetraacetate. Please remember that EDTA is a one type of a hexadentate ligand. EDTA is a one type of a hexadentate ligand. Hexadentate ligand, EDTA, hexadentate ligand. Hexadented ligand, EDTA. EDTA, hexadented ligand. Keep it in your mind. Sometimes the competition exam, direct question they are asking, which of the following is an hexadented ligand? EDTA. Clear? So see, what do you mean by EDTA? Ethylene diamine tetra. Write down. So ethylene diamine, two double M, ethylene diamine tetra acetate. So ethylene diamine tetra acetate ion, beta. It's not a molecule, it's an ion. So ethylene diamine tetra acetate. And they have, beta, how many donor site? 6 donor site. So what is the exact formula of ethylene diamine? We'll see, EDTA. Okay, we'll see the exact formula of EDTA. See here. The formula is, first you write down this CH2, here CH2, then you make a bond with NH, okay, sorry, nitrogen, here also nitrogen. Nitrogen can make how many bonds, beta? 3 bonds. So 1 bond is formed here, remaining is 2 bond here, again remaining is 2 bond here. So 3 bond. On single bond, all bond you write down CH, acetate ion you write down. So this is the acetate ion, CH2COO minus, CH2COO minus, CH2COO minus, CH2COO minus, out. Now see here, count the electron, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So see the how many donor sites are there, beta? This is 1 donor site, this is 2nd donor site, this is 3rd donor site, this is 4th donor site, this is 5th donor site, and this is the 6th donor sites. So this is nothing but a what? This is your ethylene diamine. And how many minus charge are appearing? -1, -2, -3, -4. So I can add the exact formula of EDTA is EDTA -4. Ethylene diamine tetraacetate ion. So there are 6 donor site here. Clear? See here. Understand once more. I will draw the structure. See the structure. Ethylene diamine. Huh? Now see here. First you draw the ethylene diamine. You know this. Okay. So see here. See here H2 ethylene. Now make a bond with amine means nitrogen. No. Now nitrogen has a capacity to make how many bonds? 3 bonds. So 1 bond is formed here. 1 bond here. 1 bond here. 1 bond here. 1 bond here. So CH2 COO minus. CH2 COO minus. CH2 COO minus. CH2 COO minus and CH2 COO minus. Now count the electron here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is donor site 1, donor site 2, donor site 3, donor site 4, donor site 5, donor site 6. So this is something but your hexadented ligand. Okay. So if you give 1 EDTA to metal bond, if you give 1 EDTA to a central metal atom, how many will make a bond? So he will make a 6 coordinate covalent bond with a single metal atom. That's why we say as a hexadented ligand. Write down this, take a screenshot and copy paste it. Then I will give you one use of EDTA which has been asked many a time in the exam. Okay? Clear this part? Write down. Written? Write down now. A specific salt of EDTA, known as calcium acetate, a specific salt of EDTA known as calcium acetate is used to bind metal ion, in chelation therapy. But what do you mean by chelation therapy? See here, for example, by chance if a human being inhale mercury or lead, so their body will get poisoning. Yes or no? Their body will get poisoned because mercury and lead are poisonous material. So if a body inhales mercury and lead, so this EDTA is given to this chelation therapy, means EDTA will be given. This EDTA will react with this mercury and it will clean the inside of the body, so the person can be saved. So that is known as a chelation therapy. Write down. A specific salt of EDTA known as calcium acetate is used to bind the metal ion in the presence of chelation therapy used for treating mercury used for treating mercury and lead poisoning. It is used in a similar to remove. It is also used to remove excess iron from the body. It is also used to remove excess iron from your body. See beta, your iron in your body, excess is also not good. You will fall, fatal disease you will get. So when your body will generate excess iron, so doctor will give you this medicine so that this EDTA by using the chelation therapy will combine with the iron and make a complex compound and will be removed from your body. So this is used as a medicine sometimes. Okay, this part. So it is used to remove the excess iron from the body. So one more topic is remaining, that is Hexadented Ligand. This also I will tell you in the next class. Okay. So write down, that's it. In the next class we will see some other topics based on this chapter. Thank you.